this is Lori and welcome to my project. I'm controlling an RGB LED with 6 push buttons using pulse width modulation. Here's the circuit I used in this project. First we start with the LED on the left with 4 leads. 3 leads control the red, green, and blue. They're connected with current limiting resistors and then connected to GPIO pins on the Raspberry Pi. And the ground lead is connected to the ground rail. Then the 6 buttons to the right of the LED are also connected to the ground rail and connected to GPIO pins on the Raspberry Pi. 2 buttons control the red, the next 2 buttons control the green, and the last 2 buttons control the blue. And I have them marked here as the one to the left makes the brightness of that color go down, and the one marked up makes the brightness go up. So how this program will work is the LED will start off, and then as you press one of the up buttons for a color, you'll increase that color's brightness a certain amount, and as you continue to press that button, the brightness of that color will go all the way up until it reaches a duty cycle of 100% or fully on. Continuing to press that up button will not provide any additional change. So to get it to go back down, you'll press the down button for that color, and as you press that, it'll go down until it reaches 0% duty cycle or fully off. So you can kind of use the 2 buttons to make the color brightness increase or decrease in the duty cycle scale. So we've learned that LED brightness changes non-linearly with duty cycle. So I put this graph together with my guess as to what that relationship would look like. And it just helped me understand that a small change then in duty cycle would, at the low end, would appear large to our eyes, whereas a large change in the duty cycle at the higher end would be hard to see. So for example, in the red, I show a duty cycle change of 0 to 10%, and that produces a perceived brightness change of almost 40%. Whereas in green, you can see a duty cycle change from 50 to 100 only produces a 7% change in the perceived brightness. So something we'll have to deal with in our program. So as we press the button, we want it to make each change equal in perceived brightness. So we'll need to make small changes in the duty cycle at the lower end, and then larger changes in the duty cycle at the higher end. So we'll use a power equation. Duty cycle equals a constant A raised to the power of the number of presses. And we'll want to pick an A so that we can divide up the duty cycle range with a certain number of button presses. And in my program, I ask the user to input how many presses they'd like to have going from off to fully on. So with that, we need to figure out what kind of A to use in the equation once we know how many presses the user would like. So we need to recognize that when the duty cycle is at 100%, we want that to equal the maximum number of presses, the number of requested presses. So that with that, the equation then becomes the constant A is equal to 100 raised to 1 over the maximum number of presses. So I found this pretty interesting, and to really get my head around it and make sure I was doing things correctly in my program, I made this table of requested number of presses, and then what would the A value be for that, and then for each button press, what would the duty cycle need to be set to as I pressed each time. And that just helped me make sure that I got it correctly. And then I did notice that once you get above about a requested number of 16 or so presses, that in the lower number of presses, you start to not see very big changes between in brightness between each press. So there probably is a point where maybe you're dividing up the range a little too finely to really see much of a change as you make a button press. So just something to keep in mind. So next I'll show how I implemented this project with code.
Here's the code I used for this project. First up, we'll import the libraries and set up the board numbering system and add in a small delay time variable. Then we'll set up the RGB LED with the red, green, and blue pin and set those up as output. Then we'll need to set up the 6 buttons. So there'll be a red down and a red up, green, down and up, blue, down and up. And then each of those needs to be set up as inputs with internal pull-up resistors. Then we'll need 6 variables to track the value of the button press on the previous loop, the value of the button state, I should say. So we'll set those up. Again, red down, red up, and green down and up, blue down and up. Then we'll need a variable to track the brightness of the red, green, and blue LED as we increase it and change it. And then we'll also need to set up the pulse with modulation objects for the red, green, and blue. And I set the frequency to 100, but I made that a variable so that we could change that if we desired only in one place. Then to make sure that the LEDs start off, I went ahead and set them to the current level of LEDs, so that's 0, so they'll start off. And then we'll need some variables to track the number of button presses, but we'll start at 0. Here's where I ask the user how many button presses they want to go from off to fully on. And then once we know that from the user, we can then calculate the correct constant, A, in our equation. And now we're ready to start the while true loop. So we'll read all 6 buttons state and see where they're at. And then we'll start comparing to the previous states to see if there have been any button presses. So let's just focus in on one color, red. So if the this section of code controls the up button for red, so we'll look at the previous value for the red button, and if it happens to be 0, that means it was pressed on the previous loop, and if it's now 1, that means it's been let go of. So now we would go into this logic. So the first thing we do is say that, well, there's been a button press, so increase it by 1, and let's calculate the LED level. Now, if we're getting close to 100, then we're going to want to just go ahead and say make it exactly 100 and reset the button presses to the max number, leaving it at num press from the user. So this means that if we're at the max and I keep hitting the button, the up button, it's going to just keep staying at 100% and at the number of button presses, the max that we've asked for. So once we get through all of that loop, we'll then change the duty cycle for the red pin, and we'll set it to the calculated LED level. And similarly for the down button, we'll look to see if it's been pressed and let go of. And then if that's the case, then we'll subtract 1 from the current button press, and we'll recalculate the LED level using our equation. And then we want to check to see if we're getting close to 0, because potentially we're coming down. So we want to make sure, are we getting close to 0? And if we are getting close to 0, then we want to just go ahead and set it at 0 and reset the number of button presses back to 0. And after all this logic, we'll go ahead and do the change duty cycle function and set it to the calculated LED level. So we'll do that for the green and the blue as well. And then I printed out the button presses and the current LED level so that we can keep track and watch as we press the buttons what's happening. Getting to the bottom of the loop, we'll set the previous to the current value and have a small delay time, and then ready to restart the loop. We'll end the program with a keyboard interrupt, and we'll make sure that all the colors are turned off as we leave the program, and we'll do the GPIO cleanup.
So here's the actual circuit I created, and I'll just give a quick flyby. So we can see the RGB LED hooked up with the resistors and the connections to the Raspberry Pi. And then here are the 6 buttons. I placed a little sheet there just so I could keep track of the up and down. And you can see they're all connected to the ground rail and then connected to the Raspberry Pi. So now it's time to see this work in action. And we'll come up here and we'll kick this off. And the first thing we'll be asked is how many button presses we want to go fully on. So I'll say 7 this time. And you can see the readout with the number of button presses and LED level for red, green, and blue. And let's come down here and start using these buttons. So everything's off, so the first thing we'll need to do is turn something on. So let's turn on the red. Press the red. Oh, and I wanted to add in this little black sheet of paper because I think it makes it a little easier to see. So the red is on, and just show the readout so you can see. So there's been 1 button press, and the LED level is at 2. So then we'll come down here, and we'll do some more button presses with red. So this is number 2, 3, 4, 5, 6, and 7. So that should be fully on if it all worked out right. And we can see that, yep, we're up to fully on. So let's just check. I'm going to press again and see if we go any higher. You can see nothing happens and the LED stays on. So now to change the red we would have to go down. So we go down. And off. And here's some green. We'll add some green in. And maybe we'll add in a little bit of blue to go with that. And I'll just show you what that looks like on the screen. You can see that it's 3 button presses for both the green and blue, and they're both at an LED level of 7. So I'll just add a little more blue just so you can watch it change. And now we'll look down and you can see what it looks like. So you can add and take away any of the colors, and I was lucky enough to have 6 buttons to do for this project, so I enjoyed making it work that way. I hope you enjoyed watching my project, and thanks for watching.